Hello everybody, welcome into another lesson. So today we are going to talk about factoring by grouping. And this method largely works when the degree of your polynomial is an odd power, such as 3 or 5 or 7, so on. So what does it mean to factor by grouping? That means if you could find any couple of terms and factor out something in common, then you'll end up having that common thing factored out times another factor to get the original expression. So let me show you here. So here you have x to the third plus x squared plus x plus 1. Well, let's look at those first two terms. X to the third plus x squared. What do they have in common? They both have an x squared in common, right? We can factor out a common x squared, which then would give you x squared times the quantity of x plus 1, plus then you would have that x plus 1. I'm going to put parentheses around it because I want to illustrate a point. So you have x squared times x plus 1, that quantity, plus the quantity of x plus 1. Now, we notice both of these terms have a common x plus 1, right? So we can factor this into x plus 1, that quantity times you'll have an x squared, plus this would just be 1 that's left, because x plus 1 times 1 would give you x plus 1. So the complete factorization would end up being x plus 1, that quantity, times x squared plus 1. That would give you the complete factorization. And yes, some of you are going to say you can factor this into the imaginary numbers. We'll get to that in another lesson, but for now we're going to just stick with the real numbers. So you have a group here, x plus 1, times another group of x squared plus 1. This is why we call it factoring by grouping. And again, this is best used for odd power polynomials. So what do we got next here? We have 10x to the third plus 20x to the second plus x plus 2. So we've been given 10x to the third plus 20x to the second plus x plus 2. Well, why don't we look at the first two terms here of this? Between 10x to the third and 20x squared, what do you have in common? You can factor out a common 10x squared, can't you? So if we factor out a common 10x squared, that'll be times the quantity of x plus 2. So you'd have 10x squared times the quantity of x plus 2, plus, well, you have another x plus 2 sitting here. Which now both terms have a common x plus 2. You can factor that out, the x plus 2. You'll take that times the quantity of 10x squared plus 1. So the complete factorization would be the quantity of x plus 2 times the quantity of 10x squared plus 1. All right, let's see. X to the third plus 3x squared plus 10x plus 30. So we've been given x to the third plus 3x squared plus 10x plus 30. Well, let's start again by looking at your first two terms. X to the third plus 3x squared. What's in common between those two? Definitely an x squared we can factor out, right? So that'd be x squared times the quantity of x plus 3. Plus, now let's look at your second two terms. Between 10x and 30, what do we have in common? We have a common 10, right? So that'd be plus 10 times the quantity of x plus 3. So now you have two terms here that both have a common x plus 3, right? So factor out your x plus 3, what you should be left with is simply x squared plus 10 for your other factor. So this is going to factor into the quantity of x plus 3 times the quantity of x squared plus 10. All right. So let's see. X to the third minus 2x to the second plus 4x minus 8. So we have x to the third minus 2x to the second plus 4x minus 8. Well, again, let's start with our first two terms. Between x to the third and negative 2x squared, what do we have in common? Definitely an x squared. So this would factor into x squared times the quantity of x minus 2. Plus now, we have between 4x and negative 8, what do those two terms have in common? They have a 4, so this would be plus 4 times the quantity of x minus 2. So what do we notice? Both terms have a common x minus 2, so you can factor out that x minus 2. You'll get that quantity simply times x squared plus 4. So this is going to factor into the quantity of x minus 2 times the quantity of x squared plus 4. All right, so we have 2x to the third minus 5x squared plus 18x minus 45. So we got 2x to the third minus 5x squared plus 18x minus 45. Well, let's look at the first two terms here. Between 2x to the third and negative 5x squared, what do they have in common? They have an x squared. So you can factor out that x squared. Then you'll have the quantity, that times the quantity of 2x minus 5. Easy enough, right? Now, let's look at 18x and negative 45. What do those have in common? They have a factor of 9 in common, right? So that would be plus 9 times the quantity of 2x minus 5. And if we look at both of these terms, they both have a 2x minus 5 in common, right? So we'll factor out that 2x minus 5. You'll get that quantity simply times x squared plus 9. So the complete factorization of this is going to end up being 2x minus 5, that quantity, times x squared plus 9. All right. Negative 2x to the third minus 4x squared minus 3x minus 6. So we have everything negative here. Everything is negative. So we have negative 2x to the third minus 4x squared minus 3x minus 6, okay? Well, look at your first two terms again. Between negative 2x to the third and negative 4x squared, what do they have in common? They have a negative 2x squared in common, right? So you can factor out negative 2x squared times the quantity of x plus 2. And then for your second, between the negative 3x and minus 6, what do those have in common? They have a negative 3 in common. So you'd have negative 3 times x plus 2. Now what do both of those terms have in common? They both have an x plus 2 in common, do they not? So this would turn into x plus 2 times the quantity of negative 2x squared minus 3. But What do negative 2x squared and negative 3 have in common? They have a negative 1, right? So we can factor out a negative sign. You should get negative of the quantity of x plus 2 times the quantity of 2x squared plus 3. Because the goal is to completely factor these. So this would all factor into negative of the quantity of x plus 2 times the quantity of 2x squared plus 3. I have about 3 more, then we're done. So let's see. 3x to the third minus 6x to the second plus x minus 2. So we have 3x to the third minus 6x squared plus x minus 2. Well, look at your first two terms. Between that 3x to the third and negative 6x squared, what do they have in common? They have a 3x squared in common. So you definitely have that going. That'll be times the quantity of x minus 2. Plus, you have another x minus 2 for your second two terms. Notice between both terms you have a common x minus 2. So this will factor into the quantity of x minus 2 times the quantity of 3x squared plus 1. So yes, you should get x minus 2 quantity times 3x squared plus 1 for your factors. Two more. Let's see, 2x to the third minus x squared plus 2x minus 1. Okay, well, so we're given 2x to the third minus x squared plus 2x minus 1. Well, look at your first two terms. Between 2x to the third and negative x squared, what do they have in common? They have an x squared in common, right? So you'll have an x squared times the quantity of 2x minus 1. Then plus you'll have a second two terms of 2x minus 1. So notice now both terms have a common 2x minus 1. So factor out your 2x minus 1. You'll end up getting that times the quantity of x squared plus 1. So this will factor into the quantity of 2x minus 1 times the quantity of x squared plus 1. And I got just one more. All right, let's see. 3x to the third minus 2x to the second minus 9x plus 6. All right, so we've been given 3x to the third minus 2x to the second minus 9x plus 6. So look at your first two terms. Between the 3x to the third and negative 2x to the second, what do they have in common? They have a common x squared, right? So you factor out that common x squared, you'll get that times 3x minus 2. Now look between negative 9 and positive 6. The idea is we want to get another factor of 3x minus 2. Your x to the third was positive, but your x to the first is negative. I'm going to suggest we factor out a negative 3 this time. So you factor out minus 3 times the quantity of 3x minus 2. And what do you know? Here's what you end up with. So x squared times the quantity of 3x minus 2 minus 3 times the quantity of 3x minus 2. Now, what do both terms have in common? They have a common 3x minus 2. Factor that out, you'll get that times the quantity of x squared minus 3. However, we're not done yet. We're not done yet by a long shot. That x squared minus 3 will factor since it's a difference of squares. Before we had sum of squares that didn't factor into any real factors. But we have a difference of squares. So this will factor further into the quantity of 3x minus 2 times the quantity of x plus the square root of 3 times the quantity of x minus the square root of 3, considering we have a difference of squares. So the complete factorization for this would be the quantity of 3x minus 2 times the quantity of x plus the square root of 3 times the quantity of x minus the square root of 3. Again, we always want to factor completely wherever we can. And factoring by grouping is best to use with odd power polynomials, such as 3, 5, 7, so on. Now in the next lesson, we're going to deal with factoring even powered polynomials, such as 4, 6, and 8, and so on. Those will actually take almost a quadratic type of term. We'll use quadratic factoring methods for those. So I hope everyone has a great night. Take care.